In this video, let's go deeper with respect to combination and analyze different scenarios. Alright, say you have n identical things, and from these n identical things you want to do three things. You want to select r things in case 1, you want to select 0 or more things in case 2, and in case 3 you want to select at least one thing. Let's try to understand these three cases. Say you have 4 identical apples. Now, in how many ways can you select 2 apples from these 4 identical apples? You can do it only in one way, right? Because if you select these 2 apples, or if you select these 2 apples, for example, both of these are one and the same, because at the end you get 2 identical apples. So no matter which 2 you take, it's the same scenario, right? Imagine you have 4 Snicker chocolates and you need to select 2 Snicker chocolates out of these 4. In how many ways can you do it? You can do it only in one way, right? Because if you select these 2 or if you select these 2, it's both one and the same. So if you want to select r things from n identical things, you can do it only in one way. Alright, let's move on. Now the next case is if you want to select 0 or more things from n identical things. Now in how many ways can you do that? You can do it in n plus 1 ways. How is that? You could either select 0, or you can select 1, or you can select 2 items, or up to n items, right? That's what you can select. And already over here we have seen that you can select r things from n identical things only in one way. Therefore, you can select 0 things in one way, that is not selecting anything. You can select one thing from n identical things in one way. You can select 2 things from n identical things in one way. Similarly, you can select n things from n identical things in one way. And this is 1 plus 1 plus 1 up to 1 over here. And over here, you're adding 1 n plus 1 times. Therefore, this is equal to n plus 1. Therefore, you can select 0 or more things from n identical things in n plus 1 ways. And what about selecting at least one thing from n identical things? You can do this in n ways, right? Because only 0 is not considered. The others remain the same. That's 1 to n. That's n times you are adding 1. That's equal to n. So you can select at least one thing from n identical things in n ways. Let's do this question. There are 5 identical chocolates of brand A, 4 identical chocolates of brand B, and 3 identical chocolates of brand C. How many different collections of chocolates can a person make selecting at least one of each kind? Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Over here, you need to select at least one chocolate of each kind. Now, it's mentioned that you have 5 identical chocolates of brand A. Let me denote this as A. You have 4 identical chocolates of brand B. Let me denote that over here. And similarly, you have 3 identical chocolates of brand C. Alright, now you need to select at least one of each kind, right? Now, in how many ways can you select at least one of brand A? You can do that either by selecting 1 or 2 or 3 or 4 or 5 chocolates of brand A, right? And these are identical. Therefore, you can select one chocolate from 5 chocolates in one way. You can select 2 chocolates in one way. You can select 3 chocolates in one way. And similarly, you can select 4 and 5 chocolates in one way. Therefore, you can select at least one chocolate of brand A in n ways, which is 5 in this case. Alright, now what about brand B and C? You can do that in 4 and 3 ways respectively. Alright, now therefore you can select at least one of A and at least one of B and at least one of C in 5 into 4 into 3 ways, which is equal to 60, which is your answer. Let's do this question. There are 5 identical chocolates of A, 4 of B, and 3 of C. It's the same as the previous question. The question is, how many different collections of chocolates can a person make? It does not mention that you have to select at least one of each kind. That's the difference. Alright, let's do this question. You have 5 of A, 4 of B, and 3 of C, right? Now, in how many ways can you select 0 or more from A? we already know that at least one can be selected in 5 ways, right? You can select one in one way, 2 chocolates in one way, 3 chocolates in one way, 4 chocolates in one way, and 5 chocolates in one way. Now over here you have 0 or more. Therefore, the only case that you need to add to this is selecting 0 of A, which is +1, and 5 plus 1 gives you 6 ways of selecting 0 or more chocolates of brand A. Similarly, for brand B and C, it's 5 and 4 ways respectively. Now, therefore, you can select 0 or more of A and 0 or more of B and 0 or more of C in 6 into 5 into 4 ways, right? Whenever you have and, you have to multiply. And this does not give you the answer. You have to subtract 1 from this. Why? This is the case where you select 0 of A, 0 of B and 0 of C, right? If you select no chocolate, that does not make a collection of chocolates. Therefore, you need to subtract the case where you take 0 of A and 0 of B and 0 of C. Therefore, your answer is 120 minus 1, which gives you 119 as your answer. Let's do this question. Find the number of factors of 72. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. This is typically a question that you come across in numbers, right? And this is an application of permutation and combination in numbers. The first step over here is to prime factorize 72. Let's do that over here. You can see that 72 is equal to 2 cube into 3 square, right? Now, we need to find the number of factors of 72. Over here, we have 3 2's and 2 3's, right? That's identical to saying I have 3 equivalent items and each item is 2. Similarly, I have 2 identical items and each item is 3. Therefore, to find the number of factors, I need to take 0 or more 2's and I need to take 0 or more 3's, right? Now, you can note that 2's are identical and 3's are identical. 1 2 and the other 2 both are identical. Alright, over here you have 3 2's. Therefore, you can take 0 or more 2's in n plus 1 ways, which is equal to 3 plus 1. Similarly, over here you have 2 3's. Therefore, you can take 0 or more 3's in n plus 1 ways, which is equal to 2 plus 1. Alright. Now, therefore, you can take 0 or more 2's and 0 or more 3's in 3 plus 1 into 2 plus 1 ways, which is equal to 4 into 3, which gives you 12, which is your answer. Let's move on in understanding combination in greater depth. Alright, over here we had seen 3 cases where we had to select things from identical things. Now, let's move on and analyze the case where we have to select things from different things. And over here also we have 3 cases to analyze. Say you want to select R things from N different things. Alright. Now over here, as the items are different, you can select R things from N different things in NCR ways. Right. That's what we defined combination to be, which is the number of ways of selecting R things from N things. Alright. Now, in how many ways can you select 0 or more things from N different things? You can either select 0 items or 1 or 2 up to N. You can select 0 items from N different things in NC0 ways. You can select 1 item in NC1 way. You can select 2 items in NC2 ways. Similarly, you can select N items in NCN ways. Alright. Therefore, the answer to this, which is selecting 0 or more items from N different items, is equal to NC0 plus NC1 plus NC2 up to NCN. And this is equal to 2 to the power N. Alright. Now, that's an interesting thing to note. NC0 plus NC1 up to NCN is equal to 2 to the power N. Alright. Now, in this case over here, we need to select at least one from N different things. This is the same over here, except that we don't take this into consideration. So that is equal to NC1 plus NC2 up to NCN, which is the same as 2 to the power N minus NC0. And NC0 is equal to 1, right? It's the number of ways in which 0 items can be selected from n items. That's logically 1, right? Or do it with the formula nc0 is n factorial divided by 0 factorial into n minus 0 factorial, which is n factorial itself, right? So n factorial and n factorial gets cancelled out, and 0 factorial is equal to 1. Therefore nc0 is equal to 1. So this over here becomes 2 to the power n minus 1. Let's do this question. Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. A shop has 3 categories of goods, right? Trousers, shirts and gloves. There are 5 different trousers, 4 different shirts, 3 different gloves, right? There is just one quantity of each of the above mentioned items. How many different shopping carts can a person make? And in option A, in this question, you have to select at least one of each category. Alright, let's do this question first. So we have 5 different trousers, right? Of these 5 different trousers, in how many ways can you select one or more trouser? You can do that in 5c1 plus 5c2, etc. up to 5c5 ways, right? And this we have seen is equal to 2 to the power 5 minus 1, which is equal to 32 minus 1, which is 31. Alright, now the same way, how many ways can you select one or more shirt? You have 4 shirts, right? So in case of shirts, you can do it in 2 to the power 4 minus 1 ways, right? And in the case of gloves, you can do it in 2 to the power 3 minus 1 ways. Alright, this one over here is 31, this is 15 and this is 7. Therefore, you can select one or more trousers and one or more shirts and one or more gloves in 31 into 15 into 7 ways. Alright, that's your answer to the first question. Let's see question B over here. Over here it's mentioned that at least one item is to be bought across categories. So at the end, your shopping cart should have at least one item. Alright, let's do this question. In the case of trousers, in how many ways can you select 0 or more trousers? You can do that in n 5c0 plus 5c1 plus 5c2 etc. 5c5 ways, right? And we have seen that is equal to 2 to the power 5, right? Alright, and in the case of shirts, you can do it in 2 to the power 4 ways, and in the case of gloves, you can do it in 2 to the power 3 ways. Therefore, you can select 0 or more trousers and 0 or more shirts and 0 or more gloves in 2 to the power 5 into 2 to the power 4 into 2 to the power 3 ways. But this is not your answer. From this, you have to subtract 1, which is the case where you take 0 of all the 3. That is, you buy 0 trousers, 0 shirts and 0 gloves. This case has to be subtracted because the question mentions that at least one item has to be bought across the categories. So this is your answer, which is equal to 2 to the power 12 minus 1, which is equal to 4095.